To write an equation of a line in 3D space, we said that we need a point and the direction of the line. Once we come to the planes, as you can see, this is our 3D space, and we are trying to find the equation of this plane that is shown with the blue. And to be able to write an equation of a plane in 3D space, we need again a point on that plane, which is P0, it's shown in here. And we also need the normal vector of this plane. So what is normal vector? It's the vector which is orthogonal to this plane. As you can see, this vector and this plane has a 90 degree between them. So it's orthogonal, perpendicular. So once you have this point and this normal vector n, you can write the equation of this plane. And from here you can see that for the P0 point, we can define a vector from 0 to P0, which is R0 vector. And you know that the components will be x0, y0, z0, right? Because x0 minus 0, y0 minus 0, z0 minus 0. It's going to give the components of the R0 vector. And if you take some vector P on that plane, and in here you can see that this n and r minus r0 vector, which is defined from R to R0 here, is perpendicular, which is n dot R minus R0 will be 0, because you know that if two vectors are orthogonal, their dot product should be 0. That's where we can write the equation of a plane. So our equation of a plane will be n dot R minus R0 equals 0. And exactly from that definition, here you go. It's called the vector equation of the plane, and if you write the component form, you can write the equation of a plane in a equation form that you are familiar with. So let's say n components are a, b, c. For the r vector, let's say its components are x, y, z. R0 vector x, y, x0, y0, z0. If you write that n is a, b, c, r minus r0 will be x minus x0, y minus y0, z minus z0. Their dot product will be the multiplication of the corresponding components and add them. A times x minus x0 plus b times y minus y0, c times z minus z0 should be 0. And this is exactly the scalar equation of the plane through the point P0 with the normal vector n. So you need a point and the normal vector of a plane to be able to write the equation of a plane. Okay, don't forget that. Even you can distribute a, b, and c on the parentheses, and you will have ax, by, cz in here, and a times x0, b times y0, c times z0 is going to be just constants. That's why we can call them d, and d is defined in here. This is the general form of your scalar equation of the plane. Okay, as you can see, it's a linear equation. So let's do it an example. Find an equation of the plane through the point is given and normal vector is given. So we need what we have what we need. So it's easy to find that. And it says that let's find the intercept and sketch the plane. Firstly, let's write the equation of the plane according to this definition. A times x minus x0, b y minus y0, c z minus z0, and here is given, which is a, b, c, 3, 1, 2. R0 is given, 4, 0, minus 3, which is x0, y0, z0. That's why I can write that a, 3, minus x minus x0, 4, 1 times y minus 0, 2 times z minus 3, which is going to be plus 3, equals 0. And from there, just distribute the constants. You will have 3x plus minus 12, y, 2z plus 6, 0. Then 3x plus y plus 2z equals 6. This is your linear equation of the plane. And to be able to find the intercepts of x, y, and z axis, you need to give zeros for the others. For the x-intercept, give y and z 0. 3x will be 6, x will be 2. For y-intercept, give x and z 0, y will be 6. And for the z-intercept, give x and y 0, then z will be 3. And since you know these intercepts, you can write or plot the part of the plane in the 3D space, as you can see. Okay? This is just one simple example. Let's look at another one. Find an equation of the plane that passes through the points. So 3 points are given. You have the 3 points and you want to write the equation of that plane. But what you need is 1 point and the normal vector. So what you need to find is the normal vector from the given 3 points. How can you find that? If you call them again PQR points, you can define PQ vector and PR vector. This is exactly what I did here. I defined the PQ vector, which is 8 minus 3, 5, 2 minus 1, 3, 4 minus 2, 2, right? I defined a vector from P point to Q point, which is PQ vector. And after that, I defined PR vector. Minus 1, minus 3, minus 4, minus 2, minus 1, minus 1. As you can see, from P to R, I defined a vector. So, in the plane, I have 2 vectors defined like that. Okay, this is not the same, but think about that. And if I have 2 vectors, I can find easily the vector that is orthogonal to those 2 vectors by using the cross product, right? Remember that the meaning of a cross product is you will find another vector that will be orthogonal to both of these vectors. That's why once you have PQ and PR, you can take the cross product of them and you will find a vector that will be orthogonal to both PQ and PR. Which means that since your PQ and PR vectors are on your plane, this vector is going to be orthogonal to that plane, which will be your normal vector. Okay? So this is your normal vector. Just take one of those points and you can write your equation easily. 13 minus x minus 3. It seems I took that one in this example, but you can take this one, take that one. As you can see, the equation of a plane is not unique also. It depends on the point you are taking. So here you go. You can write your equation as a minus x 0, b y minus y 0, c z minus z 0. A, b, c are the normal vector components, and x0, y0, z0 is the point that you used. I don't know, you can use any of it. Okay, this will be your equation of that plane. And another question, find the point at which the line with parametric equations, so this is the line equation, remember that, intersects the given plane. This is the plane equation. Okay, check that. This is a line equation, this is the plane equation. You know already how we were writing that. Remember it, okay? And we are trying to find the intersection. So intersection means that solve them together. Since the line equation is given in a parametric form, just plug in x, y, z inside the plane equation. X is 3 minus t, y is 2 plus t, z is 5t. Just plug in, solve for t, t will be 1. If t will be 1, just plug in x, y, z and find the intersection point. So it will be x is 2, y is 3, z is 5. It's that easy. Just solve them together. Okay? So another one, where does the line through these 2 points intersect the plane? So this time line equation is not given, but the question is exactly the same as this one, but what you need to do is write the equation of a line. And you know how to write the equation of a line, right? Direction vector, you can define from this point to that point. We did that example, which will be 3 minus 2, 1, 4 minus 1, 3, minus 2 minus 0, minus 2, 2 minus 1, 1. So this is your direction. Take the point 1, 0, 1. You can write the equation of a line, which will be x0 plus at. A is 3, b is minus 2, c is 1, and here x0, y0, z0. And you can write easily the equation of a line. And after that, this is the same what we did just a minute before. Just plugged in those inside your plane equation. Solve for t and plugged in t for your parametric equation to find the intersection point. Okay? So it should be crystal clear. So 2 planes are parallel if their normal vectors are parallel, of course. If 2 planes are not parallel, then they intersect in a straight line. And the angle between the 2 planes is the angle between their normal vectors. So by just checking their normal vectors, you can have an idea about the planes. Okay, as you can see here, this is the normal vector for the above plane, and one is the normal vector for the base plane, and the angle between them, this theta, is the same as the theta between their normal vectors. Okay, so that's why we can find the cosine of the angle between the planes by using this idea. Okay, what we need to do is use the normal vectors, and your normal vectors are a, b, c, which will be coming as the coefficients of x, y, z in the linear equation of a plane. That's why the first plane's normal vector is 1, 1, 1. Second one is 1, 2, 3. And to be able to find the angle between two vectors, what you were doing, you can use the dot product. You know that the dot product will be the first one's length times the second one length times the cosine theta. So once you solve this one for cosine theta, take the dot product over the multiplication of their length. So dot product 1 times 1, 1 times 2, 1 times 3, sum them up 6. Length of this one, 1 square, 1 square, 1 square, which is going to be 3 square root of 3, 1 square, 2 square, 3 square, square root of 14, and you can find the cosine of this theta. And you can just take the arc cosine and you can find this theta. Okay? Since it says find the cosine of the angle, that will be enough for that question. And I provide you different examples here. Make sure that you understand each one of them. We will discuss it more on Saturday. Find the symmetric equations for the line of intersection of the planes. So as we said, if two planes are intersecting, they are going to be intersecting on a line. And here you can see that. See, this is the line of intersection. And we need to find the equation of that line. And these are the given plane equations. So if you set the z0, you are trying to find a point because you are trying to write the equation of a line. What you need? A direction and a point. To find the point of this intersection, we can assume z is 0 and solve these equations together. So if z is 0, 4x plus 3y is 5, 2x minus y is 5, you can easily solve them together and you will get x is 2, y is minus 1, z we already assumed as 0. So this is your intersection point. And once you have that, you need the direction of the line. And to be able to find that, we again, for the planes, we need to use the normal vectors. So if you take the cross product of the normal vectors, you will find a vector that will be orthogonal to both of these planes. And in here, check that out, this line is gonna be orthogonal to both of these n1 and n2 vector, which are the normal vectors. That's why normal vector of that one is 4, 3, this shouldn't be minus 5, this should be actually 1, and this will be again 1. I did something wrong in here, but you can correct it out. You need to take the cross product, and the resulted vector will be your direction of the line. And since you found the point by this direction and that point, you can easily write the symmetric equation for that line. Okay? And this is for the finding the formula for the distance d from the point P to the plane. And here you go, from this point P to the plane, how can you find that distance? By using the projection of P on D, you can easily write this equation. This is the n dot b over n in here, b is in here. And for the plane equation, a x minus x0, b y minus y0, c z minus z0, a, b, c are the normal vectors, and b is, as you can see here, x1, y1 and z1 forms of this equation. Once you take the dot product, you are just calculating like that, and the length of n is just the denominator, as you can see. And from this equation, you can find the distance from a point P to the given plane. Okay, here you go. You can use that one. And this is just one application for that. What you need to do is just plug in from the formula in here. Okay. Here, as you can see, ax1, by1, cz1 plus d. Here you go. X is minus 6, 2y is minus 6, 4z is 20. You are just plugged in this point inside the plane over 1 square 4, 16, and you can find that distance easily. Okay. I also provide another example here for you, very similar one. Check that out. We will discuss it on Saturday.